Welcome to lesson 6 on some existing examples of smart microgrids in Africa. I'm Aditya Dhanvate from Smart Innovation Norway, and I'll be presenting you with this lesson. Let us start with the overview of the presentation and what you will learn in this video. First, we'll revisit the concept of smart microgrid. Secondly, we will understand the different use cases and examples for microgrids. Thirdly, we'll see some current and future trends for microgrids in the African context. But before that, let's analyze why smart microgrids are needed in the African rural areas. In general, smart microgrids are needed in African rural areas for several reasons. One of the main reasons is that they offer a promising solution for electrifying Africa's rural communities and advancing the transition to clean energy. They also offer promising solutions for electrifying Africa's traditional grid expansion, including lower costs, greater flexibility, and easier integration of renewable energy sources. Microgrids can help expand into a more renewable energy mix, providing an easier way of integrating renewable and cleaner energy sources into the energy landscape. Additionally, energy poverty is particularly prevalent in deep rural areas that are far from the main grid and are too costly to electrify by grid extension. Microgrids are emerging as an effective off-grid solution that can close the energy poverty gap and supplement existing electrification programs. Further, let's take a look and briefly revisit the concept of smart microgrids. The figure shows the different components for a microgrid. A smart microgrid is a small-scale power grid that can operate independently or in conjunction with the area's main electrical grid. It can generate, distribute, and regulate the flow of electricity to multiple buildings or households. Smart microgrids can integrate renewable energy sources such as solar and wind power and use advanced control systems to manage the flow of electricity, improving energy efficiency and reducing costs. There are several companies globally working in the domain of smart microgrids. However, to name a few companies working in the African context include Energy City, PowerGen, Sunkofa Energy, Power Hive, Mesh Power, and Husk Power Systems, which have been working with several projects related to microgrids in Africa. Next, we'll go through some of the use cases or examples where microgrids have important applications. First is buildings and households, where microgrids can play a significant role in improving the quality of life in rural areas by providing reliable and sustainable energy to buildings and households. Here are some few use cases and examples for rural microgrids in buildings and households, where first is lighting, power for lighting in homes and community buildings, improving safety and extending the hours of productivity. In cooking, power for electricity, electric cooking appliances, reducing the reliance on traditional biomass fuels, which can have negative health and environmental impacts. In heating and cooling, power can be used for heating and cooling systems, improving the comfort and health of residents. For pumping systems, to provide access to clean water for households and communities, and in communication, where power can be used for communication devices such as mobile phones and radios, improving connectivity and access to information. In healthcare, microgrids play a crucial role in improving the healthcare in rural Africa. Let's see some of the use cases and examples for rural microgrids in healthcare. First is powering medical equipment, where reliable power for medical equipment such as X-ray machines, ultrasound machines, and laboratory equipment can improve the quality of healthcare in rural areas. In refrigeration, the power can allow vaccines, and other temperature-sensitive medications to be stored safely, which can improve the availability of essential medications in rural areas. In lighting, healthcare facilities for allowing medical procedures to be performed safely and effectively, and in telemedicine for allowing healthcare facilities to connect with specialists in other locations, which can improve access to specialized medical care in rural areas. In agriculture, microgrids have a significant impact. Let us see some examples for rural microgrids in agriculture. First, for irrigation purposes, pro microgrids provide reliable power for irrigation systems, allowing farmers to grow crops in areas where traditional grid power may not be available. This can increase crop yields and improve food security. Second, in cold storage, where microgrids provide power for cold storage facilities, allowing farmers to store their produce for longer periods of time. This can reduce food waste and improve the quality of the produce. In processing, where power can be used for in processing facilities, allowing farmers to process their crops on site, this can increase the value of the crops and provide additional income for farmers. And in lighting greenhouses, allowing farmers to extend the growing season and increase the crop yields. Thus, by providing reliable and sustainable energy, microgrids have the potential to improve the livelihoods of farmers, citizens, and increase food security in the region. But there are several challenges in implementing microgrids, and some of these include regulatory challenges, where microgrids often face challenge as compared to the national utility counterparts due to imbalance in subsidy allocation, government mandates for tariff between off-grid and on-grid power consumers, and lack of supportive regulatory environment for microgrid project developers. Secondly, the upfront costs for setting up a microgrid can be high, which can be a barrier for implementation in some areas. The energy storage may pose a challenge to implement microgrids in some areas due to high cost and technical considerations. Even there are some environmental concerns for disposal of batteries and other components. So there are some of the these are some of the challenges that need to be addressed to successfully implement microgrids in African countries. But despite these challenges, microgrids have the potential to provide energy to communities that may not have access to traditional power. Thus, now we look into some trends for microgrids in Africa. As per the targets set by the African Union, the Agenda 2063 goals consider the current sustainable development goals and its relevance for the microgrid domain. Goal 1 aims for high standard of living, quality of life, and well-being for all citizens is relevant for enhancing energy access, which leads to socio-economic well-being, job creation, entrepreneurship, and industrialization opportunities. Goal 7 aims for environmentally sustainable and climate-resilient economies and communities, which improves the uptake of microgrids and reduce dependency on fossil fuels. Goal 10 aims that world-class infrastructure crisscrosses Africa. Thus, the high installation of microgrid infrastructure will promote the adoption of emerging technologies for affordable energy and fulfill Africa's needs. So, considering the brief understanding about the various aspects of microgrids, this slide sums up what we have learned in this lesson. Thank you for your time and attention.